This is the final presentation of Train 3 Motions 5 group, responsible for the driving motor and control box design and assembly. In this presentation, we will detail how close the final product was to the product specified in the design document and what the original specified product was. Subsystem 1 consisted of a motor connected to a motor controller, which accepted control signals from an Arduino and transformed those into varied motor outputs. Subsystem 1, that being the motor, is completely functional, capable of moving both forward, backwards, and decreasing or increasing speed as is required. This subsystem functions outside the system as set out in the requirements document, however, did not function when integrated with the system. It is difficult to say how well Subsystem 1 integrates with the train, as the train is non-functional. However, as the motor itself was operating outside of the system, it is safe to conclude that Subsystem 1 does not integrate with the train. This is most likely a consequence of a lack of time for integration, which in turn was a consequence of poor time management and coordination. Note that the train seemed to be stuck in a door closing state, so the issue is most likely a color assignment issue in the code of the train. Given time, the issue could be remedied, but combined with the constant pushing back of tasks cutting into integration time, time was short for the project. Subsystem 1 is of a high quality build. The wires are neat and well organized and fit seamlessly into the rest of the build. Alone, the motor is not prone to errors, except overheating associated with prolonged usage. Prolonged defined as continuous usage for over an hour. The motor integrates well with the system, operating with the system as required. Subsystem 2 consisted of a control box with 4 buttons and an LCD screen which displayed the current status of the train, linked to the train by Bluetooth. The control box would send signals to the train, which would alter the state the train was currently in. Subsystem 2 is of a low quality build. The wires are impossible to follow, the internal box is overpacked, and the wires tend to come loose. However, on the outside, the buttons are well built and aligned properly. The LCD screen also fits well to the box, but the buttons are not labeled. This, combined with the misuse of pins, means it's impossible to identify which button performs what operation. Subsystem 2, that being the control box, is only semi-functional. The semi-functionality being that the LCD screen is functioning and capable of displaying varying states as is required. However, the buttons of the control box are non-functional, only giving inputs on occasion and only giving one continuous input after an input is given. This subsystem does not function inside or outside the system and features many faults and errors. However, it should be noted that Subsystem 2 was made functional after the project was submitted. Subsystem 2, on the other hand, completely fails to come close to integrating with the project. While in testing, it was possible to get Bluetooth to connect. When it came to operation of the train, mistakes cascaded together and the control box was completely non-functional. This is due to the complex wiring used inside the box, leading to wiring errors and misplacements, together with last-minute coding to get the box into a hopefully operational state. Of course, that never occurred and the box remained non-functional. While individually components could be made to work, integrating together, issues began to arise that were not foreseen beforehand. With the continual cutting of integration time and the underestimation of the workload integration tasks would bring, our project was setting ourselves up for failure. Naturally, the blame for this entire project failing cannot be set upon one team. While it may be possible to point to specific groups who may have done their tasks poorly or incorrectly, it then falls upon the other groups to point this out to them. This feedback, while existing, was lacking when it did occur within our project. Our task could have been achieved to a much greater degree if, for instance, the structures teams better communicated their progress with the motions team, or if the comms teams better explained the requirements to the structures teams. Hence, overall, the project was not achieved to the client's specified goals. The system does not function as was laid out in the requirements document.